All right. Before we get started too much, I want to make sure everybody acknowledges the fact that these review guides and the kind of key ideas to those review guides, the keys that we've been posting, and most of these worksheets and everything, how easily these units throughout the year have been running, are due to Mr. Moss's hard work. So if you haven't already, tell Mr. Moss how much you love his teaching, his worksheets. When you see him, he's planning to retire next year and not come back and teach. So make sure you tell him you'd rather him come back and teach and skip the whole retirement thing. Um, but yeah, no, give him a hard time. Tell him you love his teaching and you love all the sheets and everything. If you do, if you don't, then maybe you don't have to. Anyway, um, sheet one, this kind of conceptual piece of things. We've got a metronome, something that bounces back and forth constantly, a simple harmonic motion. And so we know that it bounces 40 times in 20 seconds. We want to calculate both the period and the frequency here. So the period is going to be equal to the time divided by the number of cycles. And so that's just going to be 20 seconds divided by 40 cycles. And so that's 0.5 seconds per cycle. Now, this shows us that things start to move faster and faster. Period stops making a lot of sense. And instead of using period, which is going to be a very small number, we're going to use frequency, which is going to get bigger and bigger with that. So frequency is just the inverse of period. Now I'm going to show the full calculation here. We can say number of cycles divided by the time. And so that's going to be 40 over 20. So that would be 2 hertz for that, right? So then we get to the next thing, you're looking at a xylophone here. Which metal strip would have the highest velocity for each one? So this gets at the idea of calculating speed and frequency and wavelength. So how you calculate velocity equals wavelength times frequency, versus what causes velocity to change. So again, wavelength and frequency do not affect the velocity. So we're not using that equation here. The medium is the only thing that affects it. And so you look at the different medium here and you see, oh, it's all the same thing. They're all little pieces of metal. And so it's all going to have the same speed. So that's the medium piece. But we can then calculate that speed based off frequency and wavelength. So next question, though, says which one would have the highest frequency? No. Well, that's going to be a property of the actual material here. So if you look at each of those things, they're all going to resonate. So that's the first idea of resonance, right? And resonance is based off the physical properties of it. So you see the longer ones are going to have longer wavelengths here. So that red one there is going to have the biggest wavelength, and the purple one there is going to have the shortest wavelength. But since velocity is going to stay constant, then that's wavelength times frequency. The smaller the wavelength, the bigger the frequency. And so the shortest will have the highest frequency. And then we get to the end here. Now, this one does deal with a pendulum. I believe we did more of a spring pendulum type thing. So the effects on the pendulum, as far as a swing, you're not that worried about. We'll talk about it though. But the first one you definitely should be able to figure out, right? So how should you pump your legs? So they claim that this make the swing go higher. The frequency that you pump your legs related to the frequency of the swing. How should that frequency be related to the frequency? So you should pump your legs at the same frequency of the swing. That's the idea of resonance. So you have to find the same frequency that the object has. And then the next one claims that the period of the person depends only on the following one of the following variables. Which one has an effect? It was the length, but again, we went to more of a spring pendulum with this, so I wouldn't worry too much about that one there. All right, so that is the first page.